Welcome to the Slumber Lab, where science meets serenity and curiosity finds its rest. I'm so glad you're here tonight, settling into your favorite spot, maybe already feeling that gentle pull towards sleep. Whether you're wrapped in blankets, lying in the dark, or just letting your thoughts drift across the ceiling, this space is made for you. Tonight, we begin a journey into the fundamental building blocks of everything you've ever touched, seen, or dreamed about. We're diving deep into atoms, those impossibly tiny architects of reality. But we won't rush there. We'll take our time, letting each idea unfold like a soft breath. Because the most profound truths in science deserve to be savored, not hurried. Before we drift into the microscopic world together, take a moment to like this video if you're enjoying the calm approach to science, and maybe subscribe if you'd like more gentle explorations of the universe. I love hearing where you're listening from and what time it is in your corner of the world. There's something beautiful about knowing we're all connected across different time zones, sharing this quiet moment of wonder. Now, dim those lights if you haven't already. Maybe adjust your pillow. Find that perfect position. Let's ease into tonight's journey together. Imagine for a moment that you could shrink yourself down, smaller than anything you can picture. Smaller than a grain of sand. Smaller than a speck of dust. Smaller than the tiniest thing your mind can conjure. Keep going. Shrink down past the limits of what any microscope has ever seen. Past the realm where light itself becomes too big and clumsy to show you what's there. You're entering a world that exists everywhere around you, yet remains completely hidden from your senses. A world where the solid table beside your bed, the air you're breathing, even your own body, reveal themselves to be something entirely different from what they appear. This is the atomic realm, and it's been the greatest magic trick in the universe, hiding in plain sight for all of human history. Every single thing you've ever encountered, from the softest cotton to the hardest diamond, from the water you drink to the stars that shine above, is made of atoms. And here's what makes this absolutely mind-bending. These atoms are mostly empty space. The chair you're sitting on, the phone in your hand, your own skin, they're all composed of particles so small and so separated that they're essentially clouds of possibility, held together by invisible forces. But tonight isn't just about facts and figures. We're going to explore what atoms really mean for how we understand reality itself. Because once you truly grasp what atoms are, how they behave, and how they combine to create everything in existence, you'll never look at the world the same way again. You'll understand that the boundary between you and the universe isn't nearly as clear as it seems. We'll discover that atoms aren't just the building blocks of matter, they're storytellers. Each one carries a history that stretches back billions of years. The carbon in your body was forged in the heart of a dying star. The oxygen you breathe was created when that star exploded in a supernova. The iron in your blood was scattered across space by cosmic violence and slowly gathered into planets over eons of time. You are literally made of stardust, but not in some poetic, metaphorical sense. You are made of stardust in the most literal scientific way possible. And tonight, as we journey through the atomic landscape, you'll feel that connection to the cosmos in your bones. But let's start at the beginning, with a question that humans have been asking for thousands of years. What is the smallest piece of something that still remains that thing? Picture an apple. You can cut it in half, and each piece is still recognizably apple. Cut those pieces in half, and you still have apple. Keep cutting, smaller and smaller. At what point does it stop being apple and become something else entirely? This question haunted ancient philosophers. Around 400 BCE, a Greek thinker named Democritus proposed something radical. He suggested that if you kept cutting that apple into smaller and smaller pieces, you would eventually reach a point where you couldn't cut anymore. You'd arrive at the smallest possible piece of matter, something indivisible, something he called atomos, meaning uncuttable. Democritus imagined these atoms as tiny solid particles, like invisible Lego blocks that combined in different ways to create all the different materials in the world. It was a beautiful idea, and in many ways, he was remarkably close to what we now know to be true. But the reality of atoms turned out to be far stranger and more wonderful than even Democritus could have imagined. For over 2,000 years, the idea of atoms remained just that, an idea. There was no way to test it, no way to see these supposed tiny particles. Scientists could theorize about them, but atoms belonged more to philosophy than to experimental science. It wasn't until the early 1800s that atoms began their journey from speculation to scientific fact. The first real evidence came from a quiet English schoolteacher named John Dalton. Dalton noticed something peculiar about chemical reactions. When different substances combined, they always did so in very specific proportions. Water, for instance, was always made of hydrogen and oxygen in exactly the same ratio. Salt was always sodium and chlorine in the same proportions. This suggested that matter might indeed be made of discrete, indivisible particles that combined in fixed numbers. Dalton's atomic theory was elegant in its simplicity. He proposed that each element was made of its own unique type of atom, that these atoms couldn't be created or destroyed in chemical reactions, and that compounds formed when atoms of different elements joined together in simple, whole number ratios. But even Dalton couldn't have predicted what scientists would discover when they finally found ways to peer inside the atom itself. Because atoms, it turned out, were not the solid, indivisible particles that Democritus had imagined. They were something far more mysterious. The first crack in the solid atom model came in 1897, when a British physicist named J. Thomson was experimenting with electric currents in glass tubes. He discovered something unexpected: tiny particles with negative electric charge that seemed to be coming from inside the atoms themselves. He called these particles electrons, and their discovery meant that atoms weren't indivisible after all. They had internal structure. Thomson proposed what became known as the plum pudding model of the atom. He imagined atoms as spheres of positive charge with tiny negative electrons scattered throughout, like raisins in a pudding. It was a reasonable guess, based on the evidence available at the time, but it was about to be completely overturned by one of the most shocking experiments in the history of science. In 1909, a former student of Thomson's named Ernest Rutherford decided to test the plum pudding model by firing tiny particles at a thin sheet of gold foil. If atoms really were like soft puddings with electrons scattered throughout, these particles should have passed through easily, perhaps deflecting slightly. What happened instead changed our understanding of reality forever. Most of the particles did pass straight through, just as expected. But some bounced back at sharp angles, and a few even bounced straight back toward the source. Rutherford was astounded. As he later described it, it was like firing cannonballs at tissue paper and having some of them bounce back and hit you. The only way to explain these results was if atoms had a very different structure than anyone had imagined. Instead of being soft puddings, atoms had to have almost all their mass concentrated in an incredibly tiny, dense core at the center. Rutherford called this core the nucleus, and he realized that electrons must be orbiting around it at relatively vast distances. To put this in perspective, if an atom were scaled up to the size of a football stadium, the nucleus would be about the size of a marble sitting at the center of the field. The electrons would be somewhere up in the stands, but not sitting in seats, rather zipping around in the empty space. Everything else, the entire volume of the stadium, would be absolutely nothing, empty space. This revelation was staggering. It meant that everything you think of as solid, including your own body, is mostly empty space. The sensation of solidity you feel when you touch a table isn't really atoms touching atoms. It's the electromagnetic forces between electrons creating a kind of invisible barrier, like two magnets repelling each other. But Rutherford's model had a problem. According to the physics of the time, electrons orbiting a nucleus should constantly emit energy and spiral inward until they crashed into the center. Atoms should be unstable and collapse almost instantly. Yet clearly they didn't. Atoms were stable, and the world existed. There had to be something fundamentally wrong with our understanding of how the very small world behaved. The answer would come from a revolution in physics that was already beginning to unfold. Scientists were starting to realize that the rules that govern the large-scale world, the world of everyday experience, simply didn't apply at the atomic level. The microscopic realm operated according to different, much stranger principles. This is where our journey gets truly mind-bending, because we're about to enter the realm of quantum mechanics, where particles can exist in multiple places at once, where the act of observation changes reality, and where the very concept of definite position and momentum breaks down. But before we dive into that quantum wonderland, let's pause for a moment and appreciate where we are in our story. We've traveled from ancient Greek philosophy to the early 20th century, from the idea of indivisible particles to the discovery that atoms are mostly empty space held together by invisible forces. We've learned that the solid world around you is an illusion created by electromagnetic interactions between particles that are separated by distances vast compared to their own size. You are not touching your pillow right now, not in the way you think you are. You are floating just above it, held up by the mutual repulsion of electron clouds. And we're just getting started, because the story of atoms is about to take us into territories so strange that even Einstein, one of the greatest minds in human history, had trouble accepting what the evidence was telling us about the nature of reality. In the quantum world we're about to explore, particles don't have definite positions until they're observed. They exist as clouds of probability, simultaneously everywhere they could possibly be. They can tunnel through barriers that should be impossible to cross. They can be entangled with other particles across vast distances, sharing information instantaneously in ways that seem to violate everything we know about how the universe works. The atoms that make up your body are following these quantum rules right now. Every chemical reaction, every biological process, every thought in your brain depends on quantum mechanical effects that would seem like magic if you could somehow perceive them directly. And here's perhaps the most beautiful part of this story. Despite all this strangeness, despite the fact that atoms are mostly empty space following rules that defy common sense, they come together to create the rich, complex, seemingly solid world you experience every day. They create stars and planets, oceans and mountains, flowers and trees, and conscious beings like yourself who can contemplate their own atomic nature. You are a temporary arrangement of atoms that has somehow become aware of itself. You are the universe examining itself from the inside, and every atom in your body carries a story that connects you to the deepest history of the cosmos. As we prepare to journey deeper into the quantum realm in the next part of our exploration, let yourself marvel at this fact. The very atoms that allow you to think these thoughts, that create the neural networks in your brain, that enable consciousness itself, are following rules so strange and wonderful that we're still discovering new aspects of their behavior. The story of atoms is your story because you are made of them. And their story is still being written, still being discovered, still revealing new mysteries about the fundamental nature of existence itself. As you settle deeper into comfort, breathing slowly and naturally, let's continue our journey into the heart of matter itself. We're about to enter a realm where the familiar rules of everyday life dissolve into something far more mysterious and beautiful. In the early 1900s, Scientists found themselves facing a crisis. The classical physics that had worked so well for centuries was breaking down at the atomic level. Atoms weren't behaving the way they should, according to everything humanity had learned about motion, energy, and matter. It was as if nature had been keeping a secret, and that secret was about to revolutionize our understanding of existence itself. The breakthrough came from an unlikely source. Max Planck, a German physicist, was trying to solve a seemingly mundane problem about how hot objects emit light. But his solution required him to make a radical assumption that energy didn't flow smoothly like water from a faucet. Instead, it came in tiny, discrete packets that he called quanta. Planck himself didn't fully believe this idea at first. It seemed too strange, too disconnected from the continuous world we experience. But the mathematics worked perfectly, and sometimes in science, the math leads us to truths that our intuition struggles to accept. Albert Einstein took Planck's quantum idea and ran with it, using it to explain how light could knock electrons out of metal surfaces. Einstein showed that light itself came in these discrete packets, which we now call photons. Light, which had seemed like a smooth wave spreading through space, was actually made of individual particles of energy. But here's where things get truly mind-bending. These photons, these particles of light, also behave like waves. They can interfere with each other, creating patterns of bright and dark bands, just like waves on water. A single photon can somehow go through two different openings at the same time and interfere with itself. This wave-particle duality wasn't just true for light. Soon, scientists discovered that electrons, those tiny particles orbiting atomic nuclei, also behaved like waves. In fact, everything at the quantum level exhibits this strange dual nature. Matter acts like waves, and waves act like particles, depending on how you choose to observe them. Picture this. If you try to measure exactly where an electron is, it behaves like a particle with a definite location. But if you're not measuring its position, the electron exists as a wave of probability, spread out across space. It's not that we don't know where it is, it's that the electron literally doesn't have a specific location until something forces it to choose. This led to one of the most profound principles in all of science, Heisenberg's uncertainty principle. Werner Heisenberg showed that there are fundamental limits to what we can know about quantum particles. The more precisely you try to measure a particle's position, the less precisely you can know its momentum, and vice versa. This isn't due to imperfect instruments or measurement techniques. It's a fundamental feature of reality itself. The universe, at its deepest level, is built on uncertainty and probability, rather than the clockwork determinism that scientists had imagined for centuries. Einstein famously objected to this, declaring that God does not play dice with the universe. But the evidence kept mounting that at the quantum level, dice playing seemed to be exactly what was happening. Niels Bohr, the Danish physicist who became one of the founding fathers of quantum mechanics, had a different perspective. He suggested that we needed to abandon our classical intuitions entirely when thinking about the atomic world. The question of whether an electron is really a wave or really a particle was meaningless. These classical concepts simply didn't apply at the quantum scale. Bohr proposed what became known as complementarity, the idea that quantum objects have pairs of properties that cannot be measured simultaneously. Position and momentum are complementary. So are energy and time. You can know one precisely or the other precisely, but never both at the same time. This wasn't just a philosophical curiosity, it had real, practical implications for understanding atoms. In Bohr's model of the atom, electrons couldn't orbit the nucleus like planets around the sun. Instead, they existed in discrete energy levels, like steps on a ladder. An electron could be on one step or another, but never in between. When an electron jumped from a higher energy level to a lower one, it would emit a photon of light with exactly the right energy to account for the difference between levels. This explained why different elements emit light at specific colors when heated. Each element has its own unique arrangement of energy levels, creating a kind of atomic fingerprint in the light it produces. But even Bohr's model was just the beginning. As quantum mechanics developed through the 1920s, the picture of atoms became even stranger and more wonderful. Scientists like Erwin Schrödinger developed mathematical equations that could describe the probability waves of electrons around nuclei. These weren't orbits in any sense we could visualize. They were three-dimensional probability clouds, regions where an electron might be found if you tried to measure it. Some of these clouds were spherical. Others had complex shapes with lobes and nodes. The mathematics was beautiful and precise, but the physical picture it painted was unlike anything in our everyday experience. Schrödinger himself was troubled by some of the implications of his own equation. He devised a famous thought experiment involving a cat in a box with a quantum device that might or might not kill it. According to quantum mechanics, until you opened the box to check, the cat would be in a superposition of being both alive and dead simultaneously. This wasn't meant to be taken literally, of course. Schrödinger was pointing out what seemed like an absurd consequence of quantum theory. But decades of experiments have shown that quantum superposition is real for microscopic objects. Particles really can exist in multiple states at once until something forces them to choose. The implications extend far beyond just understanding atoms. Quantum mechanics explains how the sun shines through nuclear fusion. It governs the behavior of electrons in the computer circuits that might be playing this video. It makes possible the chemical reactions that power your brain and body. Every biological process, from photosynthesis in plants to the copying of DNA, depends on quantum mechanical effects. Even more remarkably, quantum mechanics has led to technologies that are reshaping our world. Lasers work because of quantum properties of light and matter. MRI machines use quantum spin to peer inside your body. Computer chips rely on quantum tunneling, the ability of particles to pass through barriers that should be impossible to cross according to classical physics. And we're just beginning to harness the strange power of quantum mechanics. Scientists are developing quantum computers that could solve certain problems exponentially faster than any classical computer. They're exploring quantum teleportation, not of objects, but of information encoded in quantum states. They're investigating quantum entanglement, the spooky action at a distance that Einstein found so troubling. But let's step back from these technological marvels and return to the atoms that make up your body. Right now, as you lie there listening to these words, trillions upon trillions of atoms are following quantum rules. The electrons in your neural networks are tunneling across synapses, enabling the electrical signals that create your thoughts. The quantum properties of molecules in your eyes are converting photons into nerve impulses, allowing you to see. Your very existence depends on the fact that atoms are stable despite being mostly empty space. This stability comes from quantum mechanics. Electrons can't spiral into the nucleus because they're not classical particles following classical orbits. They're quantum waves confined to specific energy levels by the mathematical constraints of their probability functions. The atoms in your body are constantly exchanging electrons, forming and breaking chemical bonds, rearranging themselves into new configurations. But through all this change, your sense of self persists. You feel like a continuous, solid being, even though you're actually a dynamic pattern of quantum particles in constant flux. This raises profound questions about the nature of identity and consciousness. If your atoms are constantly being replaced through metabolism, if the matter that makes up your body today is different from the matter that made up your body 7 years ago, then what exactly are you? Are you the pattern of information encoded in the arrangement of your atoms? Are you the process of quantum interactions that maintains that pattern over time? These aren't just philosophical questions anymore. As we learn more about quantum mechanics and its role in biological systems, we're discovering that consciousness itself might depend on quantum effects in the brain. Some researchers propose that the mysterious nature of consciousness, the hard problem of how subjective experience arises from objective matter, might be connected to the mysterious nature of quantum measurement and observation. The idea is still controversial and speculative, but it's remarkable to consider that the same quantum strangeness that makes atoms possible might also make consciousness possible. The observer effect in quantum mechanics, where observation changes the state of a quantum system, might be intimately connected to the fact that you are an observer, aware of your own existence. But even if consciousness doesn't directly involve quantum mechanics, the fact remains that you are a quantum being. Every atom in your body is a tiny quantum system, and the collective behavior of these quantum systems creates the classical world you experience. You are a bridge between the quantum realm and the everyday world. A living example of how quantum strangeness gives rise to classical familiarity. Think about the water molecules in your body. Each one consists of 2 hydrogen atoms and 1 oxygen atom held together by quantum mechanical bonds. The electrons are shared between the nuclei in probability clouds that create the specific shape and properties of water. These quantum interactions determine why water is liquid at room temperature, why it expands when it freezes, why it can dissolve so many other substances. The DNA in your cells is a quantum mechanical structure. The double helix is held together by hydrogen bonds that form because of the quantum properties of electrons. The genetic code is read by molecular machines that rely on quantum tunneling and other quantum effects to function with remarkable precision and speed. Even the colors you see are quantum mechanical phenomena. When light hits your retina, photons are absorbed by molecules that change their quantum state in response. This triggers a cascade of quantum-controlled chemical reactions that eventually become electrical signals in your optic nerve. The experience of seeing blue or red or green is ultimately the result of quantum interactions between light and matter. As you breathe in and out, following the natural rhythm of your body, remember that each breath involves countless quantum events. Oxygen molecules bind to hemoglobin in your blood through quantum mechanical processes. The energy that powers your cells comes from quantum mechanical reactions that break apart glucose molecules and transfer their energy to other molecules like ATP. You are not separate from the quantum world. You are not an observer looking at atoms from the outside. You are made of atoms. You are a collection of quantum systems that has somehow organized itself into a pattern complex enough to contemplate its own existence. You are the universe becoming aware of itself at the quantum level. This perspective can be both humbling and empowering. Humbling because it reminds us how much we still don't understand about the fundamental nature of reality. The quantum world continues to surprise us with new phenomena and new possibilities. Every answer we find seems to reveal new questions, deeper mysteries. But it's also empowering because it connects you to the deepest structures of reality. The same laws that govern the behavior of electrons in atoms also govern the fusion reactions in the cores of stars. The same quantum fields that create the particles in your body also permeate all of empty space. You are not an accident or an afterthought in the cosmic story. You are an integral part of it, made from its most fundamental ingredients, following its most basic laws. As you rest there, surrounded by the gentle darkness, let's journey deeper into one of the most beautiful and mysterious aspects of atomic reality. We've explored how atoms are mostly empty space, how they follow quantum rules that defy our everyday intuition. Now let's discover how these invisible building blocks come together to create the incredible diversity of matter that surrounds you. Think about the pillow beneath your head, the sheets against your skin, the air you're breathing. Each of these feels completely different, yet they're all made from the same basic ingredients: atoms. The difference lies not in the atoms themselves, but in how they choose to dance together. There are only about 90 naturally occurring types of atoms in the universe, 90 different elements, from the lightest hydrogen to the heaviest uranium. That's it. Just 90 fundamental ingredients. And yet from these simple building blocks, nature has created everything you've ever experienced. It's like having a cosmic kitchen with only 90 ingredients, but somehow creating an infinite menu of possibilities. Each type of atom, each element, is defined by a single number, the number of protons in its nucleus. Hydrogen has 1 proton, helium has 2, carbon has 6, oxygen has 8, iron has 26. This number, called the atomic number, determines everything about how that atom behaves, how it bonds with other atoms, what properties it gives to the materials it forms. But here's where the story gets even more fascinating. Atoms don't just exist in isolation. They reach out to each other, forming bonds, creating molecules, building the complex structures that make up everything from water to wood to your own DNA. And the way they do this is through their electrons, those probability clouds we talked about earlier. Imagine atoms as social beings, each with their own personality determined by their electron arrangement. Some atoms are loners, content to exist by themselves. These are the noble gases, like helium and neon, complete and satisfied with their electron configurations. Others are desperate to form connections, willing to give up or share electrons to achieve stability. Sodium, for instance, has 1 electron in its outermost shell that it's eager to give away. Chlorine has 7 electrons in its outer shell and desperately wants 1 more to complete its set of 8. When sodium meets chlorine, it's like a perfect match. Sodium gives its extra electron to chlorine, and both atoms become more stable. The result is salt, sodium chloride, a compound with properties completely different from either of its component atoms. This is one of the most remarkable things about chemistry and atomic behavior. When atoms combine, they don't just add their properties together. They create something entirely new. Sodium is a soft, silvery metal that explodes when it touches water. Chlorine is a poisonous green gas. But together, they form table salt, something you sprinkle on your food without a second thought. The water in your body tells a similar story. 2 hydrogen atoms, each with 1 proton and 1 electron, join with 1 oxygen atom, which has 8 protons and 8 electrons. The hydrogen atoms share their electrons with oxygen, creating a molecule with an entirely new set of properties. Water can dissolve more substances than almost any other liquid. It expands when it freezes, unlike most materials. It has a high boiling point for such a small molecule. None of these properties could be predicted just by looking at hydrogen and oxygen individually. But molecular formation is just the beginning. Molecules can join together to form larger structures, and these structures can organize into even more complex arrangements. The carbon atoms in your body, for example, can form long chains, branch networks, and ring structures. They can bond with hydrogen, oxygen, nitrogen, and other elements to create the proteins, fats, carbohydrates, and nucleic acids that make life possible. Consider the DNA in every cell of your body. It's essentially a very long molecule made of just 4 types of smaller molecules called nucleotides. These nucleotides are themselves made of atoms, carbon, hydrogen, oxygen, nitrogen, and phosphorus, arranged in specific patterns. But the way these nucleotides line up along the DNA strand creates a code. a set of instructions for building and maintaining your entire body. The same atoms that make up a grain of sand on a beach can, when arranged differently, become part of a living cell. The carbon in coal can become the carbon in a flower petal. The iron in a meteorite can become the iron in your blood. It's all about arrangement, about how these atomic building blocks choose to connect with each other. And here's something truly mind-bending to consider as you lie there in the darkness. The atoms in your body right now have their own ancient histories. They weren't created when you were born. They've been on an incredible journey through space and time, cycling through countless different forms and arrangements. The hydrogen atoms in the water of your cells are some of the oldest things in existence. They were created in the first few minutes after the Big Bang, when the universe was so hot and dense that protons and electrons couldn't even stay together to form stable atoms. As the universe expanded and cooled, these protons captured electrons and became hydrogen, the simplest and most abundant element in the cosmos. For millions of years, these hydrogen atoms drifted through space, slowly gathering into vast clouds of gas. Gravity pulled these clouds together, compressing them until they became dense enough and hot enough for nuclear fusion to begin. This is how the first stars were born, powered by the fusion of hydrogen into helium in their cores. But stars do more than just shine. They're cosmic factories, creating heavier elements through nuclear reactions. In the intense heat and pressure of a star's core, helium atoms can fuse to form carbon. Carbon can combine with other nuclei to create oxygen, neon, magnesium. Even heavier elements form as the star ages and its core temperature rises. When the most massive stars reach the end of their lives, they explode in spectacular supernovas, scattering these newly created elements across space. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of these were forged in the nuclear furnaces of ancient stars and dispersed by these cosmic explosions. These stellar remnants drifted through space for millions of years, eventually becoming part of the cloud of gas and dust that would form our solar system. Some of these atoms became part of the Earth, settling into rocks and oceans. Others cycled through countless generations of plants and animals before eventually becoming part of you. The carbon atom in one of your muscle cells might have once been part of a dinosaur. Before that, it could have been in an ancient tree, or dissolved in a primordial ocean, or floating free in space. The atoms that make up your body have literally been everywhere, done everything, been part of stars and planets and countless other living beings. And here's the beautiful part, they'll continue their journey long after you're gone. The atoms that are temporarily organized into the pattern that is, you will eventually become part of other structures, other patterns, other beings. You are a temporary arrangement of ancient stardust, conscious for a brief moment in cosmic time. This isn't meant to be depressing or diminishing. It's actually the opposite. It means you are intimately connected to everything else in the universe. The boundary between you and the world around you is much more fluid than it appears. You're constantly exchanging atoms with your environment through breathing, eating, drinking. The atoms that were part of you yesterday might be part of a tree tomorrow. You're not separate from nature. You are nature. You're not observing the universe from the outside. You are the universe observing itself from the inside. Every breath you take brings new atoms into your body. Every exhale sends atoms back out into the world to begin new adventures. The electromagnetic forces that hold your atoms together are the same forces that hold together the atoms in distant galaxies. The quantum mechanical laws that govern the electrons in your brain are the same laws that govern the behavior of matter everywhere in the cosmos. You are made of the same stuff as stars, and you follow the same physical laws. But you're not just any random arrangement of atoms. You're a very special arrangement, one that has somehow become self-aware, capable of contemplating its own existence. Your brain, made of carbon, hydrogen, oxygen, and other elements, has organized itself into patterns complex enough to understand patterns, to recognize beauty, to experience consciousness. This is perhaps the most remarkable thing about atoms and their arrangements. Given enough time and the right conditions, they can organize themselves into structures capable of thought, creativity, love, wonder. The universe, through you, has developed the ability to understand itself. The neurons firing in your brain right now, creating the thoughts that follow these words, are quantum mechanical systems. The electrical impulses racing along your nerve fibers depend on the movement of ions, charged atoms, across cell membranes. The chemical reactions that power your thoughts involve the making and breaking of molecular bonds, the sharing and transfer of electrons between atoms. Your consciousness, whatever it ultimately is, emerges from the collective behavior of countless atomic interactions. You are not just made of atoms, you are a process carried out by atoms, a pattern of activity that somehow gives rise to subjective experience, to the feeling of being you. And right now, as you rest there in the quiet darkness, your body is carrying out millions of atomic-scale operations every second. Proteins are folding into complex three-dimensional shapes determined by the quantum mechanical properties of their constituent atoms. Enzymes are catalyzing chemical reactions by precisely positioning atoms and molecules in their active sites. DNA is being repaired by molecular machines that can recognize and fix errors in the atomic sequence of genetic information. All of this happens below the threshold of your conscious awareness, yet it's what makes consciousness possible. Your atoms are taking care of you, maintaining the incredibly complex pattern that is your living body, allowing you to simply exist and experience and wonder. Let this sink in as you breathe slowly and naturally. Each breath brings oxygen atoms into your lungs, where they bind to iron atoms in your hemoglobin and travel through your bloodstream to every cell in your body. There, they participate in the chemical reactions that extract energy from food molecules, keeping you alive and aware. The atoms don't know they're part of you. They don't have consciousness or intention. They simply follow the laws of physics, forming bonds where they're energetically favorable, participating in reactions that are thermodynamically allowed. Yet somehow, through their collective behavior, they create and maintain something as extraordinary as your conscious experience. This is the deep mystery we're still trying to understand. How does consciousness emerge from unconscious matter? How do atoms, following simple physical laws, give rise to thoughts, feelings, memories, dreams? We don't have complete answers yet, but we do know that it happens, and that it's happening in you right now. You are a living example of the universe's creative potential, a demonstration of what's possible when atoms have billions of years to experiment with different arrangements and organizations. You are not just in the universe, you are the universe becoming aware of itself, understanding itself, appreciating its own beauty and complexity. As we prepare to explore even deeper into the atomic realm, into the forces that hold nuclei together and the particles that make up protons and neutrons themselves, remember this connection. You are not separate from what we're studying. You are made of it. Every discovery about atoms is a discovery about you, about the fundamental nature of your own existence. The story of atoms is your story because you are atoms. And their story, as we'll continue to discover, is far stranger and more wonderful than even the quantum mechanical picture we've explored so far. We're about to journey into the very heart of the nucleus, where the forces are so strong they can power stars, and where the very fabric of space and time begins to reveal its deepest secrets. But for now, rest in this knowledge. You are stardust that has learned to wonder about itself. You are the universe's way of experiencing its own existence. And you are held together by forces and following laws that connect you to everything else that has ever been or ever will be. The atoms that form the core of every element around you hold secrets that took humanity decades to uncover. As we journey deeper into the heart of matter, we're about to discover forces so powerful they can fuel the sun, yet so precisely balanced that they allow the incredible diversity of elements that make up your world. Picture the nucleus of an atom, that tiny marble at the center of our football stadium. It's not the simple, solid ball that early scientists imagined. Instead, it's a bustling collection of particles called protons and neutrons, packed together so tightly that the forces holding them would make the strongest magnets seem like gentle whispers in comparison. Each proton carries a positive electric charge, and here's where things get interesting. Like charges repel each other. If you've ever tried to push two magnets together with their same poles facing, you've felt this force. Now imagine trying to squeeze dozens of positively charged protons into a space smaller than you could ever visualize. The electrical repulsion should blow the nucleus apart instantly. Yet here you are, made of atoms with stable nuclei that have existed for billions of years. What force could possibly be strong enough to overcome this electrical repulsion and hold the nucleus together? The answer leads us to one of the four fundamental forces that govern everything in the universe, the strong nuclear force. The strong force is unlike anything you experience in your daily life. It's incredibly powerful, but incredibly short-ranged. It only works when particles are practically touching each other. But when they are, it's about 100 times stronger than the electromagnetic force trying to push the protons apart. It's like having an incredibly strong, but very short rope that can bind particles together only when they're close enough to touch. This force doesn't just hold protons together, it also binds neutrons, particles with no electric charge that share the nucleus with protons. Neutrons are crucial for nuclear stability. They act like nuclear glue, providing additional strong force attraction without adding more electrical repulsion. The delicate balance between protons and neutrons determines whether a nucleus will be stable for billions of years or decay in a fraction of a second. As you lie there breathing slowly, consider that every element in your body exists because of this balance. Carbon, with 6 protons and typically 6 neutrons, is perfectly stable. Add one more proton, and you get nitrogen. Add another, and you have oxygen. Each element along the periodic table represents a different solution to the puzzle of nuclear stability, a different way of arranging protons and neutrons so that the strong force can overcome electrical repulsion. But the story gets even more fascinating when we consider what happens when this balance is disturbed. Some arrangements of protons and neutrons are unstable, and these radioactive nuclei will eventually decay, transforming into more stable configurations. This isn't a flaw in nature's design. It's a feature that has shaped the universe in profound ways. The warmth you feel from the Earth beneath you comes partly from radioactive decay happening deep in the planet's core. Uranium and thorium nuclei, formed billions of years ago in ancient supernovas, are still slowly breaking apart, releasing energy that helps keep our planet's interior molten and drives the geological processes that make life possible. The carbon-14 in your body, absorbed from the atmosphere through the food you eat, is slowly decaying at a predictable rate. Scientists use this radioactive clock to date ancient artifacts and fossils, reading the story of the past written in the language of nuclear decay. Even your own body is slightly radioactive, containing naturally occurring isotopes that occasionally transform themselves into different elements. This nuclear alchemy isn't just happening in your body and the Earth around you. It's the process that powers every star in the night sky. In the core of the sun, hydrogen nuclei are being fused together under enormous pressure and temperature to form helium. This fusion process releases the energy that makes the sun shine, the same energy that warms your skin and powers the photosynthesis that creates the oxygen you breathe. Nuclear fusion is incredibly difficult to achieve because it requires forcing positively charged nuclei close enough together for the strong force to take over. It's like trying to push two powerful magnets together against their mutual repulsion. Only in the extreme conditions found in stellar cores, with temperatures of millions of degrees and pressures billions of times greater than Earth's atmosphere, can this fusion occur naturally. When fusion happens, something remarkable occurs. The mass of the resulting nucleus is actually slightly less than the combined mass of the original nuclei that fuse together. This missing mass hasn't disappeared. It's been converted into energy, according to Einstein's famous equation, E equals mc squared. A tiny amount of mass becomes an enormous amount of energy because the speed of light squared is such a large number. This is the secret of stellar power. The sun converts about 4 million tons of mass into energy every single second, and it's been doing this for nearly 5 billion years. The light that touches your face right now began as a fusion reaction in the sun's core, where hydrogen nuclei overcame their electrical repulsion and merged to create helium, releasing photons that took thousands of years to work their way to the sun's surface before racing across space to reach you. But fusion can create elements heavier than helium too. As stars age and their cores grow hotter, they can fuse helium into carbon, carbon into oxygen, oxygen into silicon, and so on up the periodic table. Each fusion step requires higher temperatures and pressures, and each step releases less energy than the last. Eventually, the star reaches iron, element number 26, and here the fusion process hits a wall. Iron nuclei are so stable that fusing them together actually requires energy rather than releasing it. When a massive star's core fills up with iron, fusion stops, and the star faces a crisis. Without the outward pressure from fusion reactions to balance the inward pull of gravity, the core begins to collapse catastrophically. What happens next is one of the most violent events in the universe. The stellar core collapses so rapidly that it rebounds in a tremendous explosion called a supernova. For a few brief moments, this exploding star can outshine an entire galaxy of 100 billion stars. The temperatures and pressures in a supernova are so extreme that they can forge elements heavier than iron, creating gold, platinum, uranium, and all the other heavy elements that couldn't be made in the star's normal fusion processes. The calcium in your bones was forged in the fusion furnace of an ancient star. The iron in your blood was created either in stellar fusion or in the explosive death of a massive star. The gold in any jewelry you might wear was born in the unimaginable violence of a supernova explosion. You are quite literally made of star stuff, assembled from the nuclear ashes of stellar death and rebirth. These cosmic explosions don't just create heavy elements, they scatter them across space, enriching the interstellar medium with the ingredients needed to form new stars, new planets, and eventually, new life. The cloud of gas and dust that would eventually become our solar system was seasoned with the products of countless stellar lives and deaths, a cosmic inheritance that made your existence possible. But let's zoom back down to the scale of individual nuclei and explore another mystery. We've talked about protons and neutrons as if they were fundamental particles, but they're not. Just as atoms turned out to have internal structure, protons and neutrons are themselves made of even smaller particles called quarks. Quarks are truly fundamental as far as we know, indivisible particles that come in 6 different types or flavors with whimsical names: up, down, charm, strange, top, and bottom. Protons are made of 2 up quarks and 1 down quark, while neutrons consist of 2 down quarks and 1 up quark. The difference between these arrangements is what gives protons their positive charge and leaves neutrons electrically neutral. But quarks are bound together by yet another fundamental force, the strong force we mentioned earlier. This force is carried by particles called gluons, and it has a strange property that makes quarks very different from electrons. The strong force actually gets stronger as you try to pull quarks apart, like a rubber band that becomes harder to stretch the more you extend it. This means you can never isolate a single quark. Try to pull one quark away from its companions, and you'll pump so much energy into the system that you'll create new quark-antiquark pairs before you can separate the original quarks. It's as if nature has conspired to keep quarks forever imprisoned within protons and neutrons. The mathematics describing quarks and gluons is called quantum chromodynamics, and it's one of the most successful theories in physics. It explains not just how protons and neutrons are built, but how they interact with each other to form atomic nuclei. The strong force that holds your nuclei together is actually a residual effect of the much stronger force that binds quarks within individual protons and neutrons. As you rest there, breathing naturally, your body is held together by this hierarchy of forces. Quarks are bound into protons and neutrons by the strong force. Protons and neutrons are bound into nuclei by the residual strong force. Electrons are bound to nuclei by the electromagnetic force, and atoms are bound into molecules and larger structures through electromagnetic interactions between their electron clouds. But there's one more fundamental force we haven't discussed yet, and it's the one that keeps you gently pressed against your bed. Gravity, the weakest of the four fundamental forces, yet the one that shapes the large-scale structure of the universe. While gravity is far too weak to affect individual atoms or even individual molecules, it becomes dominant when you have enormous collections of matter like planets, stars, and galaxies. Gravity is what pulled together the gas clouds that formed the first stars. It's what compressed stellar cores to the temperatures and pressures needed for fusion. It's what caused massive stars to collapse and explode as supernovas. And it's what gathered the scattered products of those explosions into new star systems like our own. Without gravity, the elements forged in ancient stars would still be dispersed throughout space, and complex structures like planets and life could never have formed. Einstein showed us that gravity isn't really a force in the traditional sense. It's a curvature in the fabric of space and time itself, created by the presence of mass and energy. Massive objects like stars and planets warp space-time around them, and other objects follow the curved paths through this warped geometry. You're not being pulled down by some mysterious gravitational force. You're simply following the straightest possible path through space-time that has been curved by the Earth's mass. This geometric view of gravity has profound implications for understanding the universe. It explains how black holes can trap light itself, how time can run slower in strong gravitational fields, and how gravitational waves ripples in space-time itself can carry information about cosmic collisions across billions of light years. But perhaps most remarkably, it suggests that space and time themselves might not be fundamental features of reality. They might emerge from something even deeper, some more basic level of description that we haven't yet discovered. Just as temperature emerges from the average motion of atoms, space-time might emerge from the collective behavior of some more fundamental constituents of reality. This brings us to one of the biggest mysteries in modern physics. We've identified four fundamental forces and discovered that matter is made of quarks and leptons like electrons. We've built a theoretical framework called the Standard Model that describes how all these particles and forces interact. This model has been tested with incredible precision and has successfully predicted the existence of new particles before they were discovered in experiments. Yet we know the Standard Model is incomplete. It doesn't include gravity, which we describe separately using Einstein's general relativity. It doesn't explain why the universe contains matter rather than antimatter, or what makes up the dark matter that seems to outweigh ordinary matter by 5-1. It doesn't account for the dark energy that appears to be accelerating the expansion of the universe. Most fundamentally, The standard model treats particles as point-like objects with no internal structure, but many physicists suspect this is just an approximation. Some theories suggest that what we call fundamental particles might actually be tiny, vibrating strings or loops in higher dimensional space. Others propose that space itself might be made of discrete units, pixels of reality, too small to detect with current technology. We're living through an exciting time in physics, where our best theories are pushing us toward new questions about the fundamental nature of reality. The atoms that make up your body are gateways to these deeper mysteries. Every electron, every quark, every photon that participates in the chemical reactions powering your thoughts is following rules that we're still working to fully understand. As you lie there in the gentle darkness, consider that you are not just made of atoms, you are made of questions. The particles in your body are following laws of physics that point toward deeper truths we haven't yet grasped. You are composed of mysteries wrapped in mathematical equations, held together by forces that challenge our most basic assumptions about the nature of existence. The boundary between the known and unknown runs right through your own body. We understand how atoms bond to form molecules, how molecules organize into cells, how cells work together to create living organisms. But the transition from non-living matter to living systems, from unconscious particles to conscious beings, remains one of the deepest puzzles in science. Your consciousness emerges somehow from the collective behavior of atoms that individually have no awareness, no intention, no purpose beyond following the laws of physics. Yet, here you are, aware of your own existence, capable of contemplating the very atoms that make you possible. The universe has organized itself into a pattern complex enough to understand patterns, to recognize beauty, to experience wonder. This is perhaps the most profound implication of atomic theory. You are not separate from the physical world you're studying. You are the physical world studying itself. The atoms in your brain, following quantum mechanical rules they have no awareness of, have somehow given rise to thoughts about quantum mechanics. The particles that make up your eyes have evolved to detect the light that other particles emit, allowing you to see and understand the atomic processes that created both the light and your ability to perceive it. Every scientific discovery about atoms is also a discovery about yourself, about the fundamental processes that make your existence possible. When we learn how stars forge heavy elements, we're learning about the origin of the calcium in our bones. When we discover new particles in accelerator experiments, we're probing the same quantum fields that permeate our own bodies. When we develop new theories about the nature of space and time, we're exploring the stage on which our own atomic drama plays out. You are the universe becoming self-aware, matter contemplating its own nature, atoms wondering about themselves. In the grand cosmic story that began with the Big Bang and will continue for trillions of years into the future, your brief moment of consciousness represents something unprecedented and precious. A temporary arrangement of particles that has achieved the ability to understand its own existence. And as you consider this remarkable fact, let's explore something that might seem like science fiction, but is happening in your body right now. We've talked about how atoms follow quantum rules, how they exist as probability clouds until measured. But there's another quantum phenomenon that's even more mysterious, one that Einstein himself called spooky action at a distance. It's called quantum entanglement, and it might be one of the keys to understanding how consciousness emerges from matter. When two particles become entangled, they form a connection that transcends ordinary space and time. Measure the spin of one entangled electron, and you instantly know the spin of its partner, no matter how far apart they are. Change the quantum state of one particle, and its entangled twin responds immediately, even if it's on the other side of the galaxy. This isn't just theory anymore. It's been demonstrated in countless experiments, and is the foundation for emerging technologies like quantum computers and quantum communication. But here's what makes this relevant to you as you rest there in the darkness. Some researchers believe that quantum entanglement might play a role in biological systems, including the neural networks in your brain. The idea is still being explored, but there's growing evidence that life has learned to harness quantum effects for everything from photosynthesis in plants to navigation in migrating birds. In your brain right now, billions of neurons are firing in complex patterns, creating the thoughts that follow these words. Each neural firing involves the movement of ions across cell membranes, quantum mechanical processes that depend on the precise positioning of atoms and molecules. Some scientists propose that consciousness might emerge not just from the electrical activity of neurons, but from quantum entanglement between molecules in your brain cells. This is still speculative, but it points to something profound about the relationship between mind and matter. If consciousness does involve quantum effects, then the boundary between observer and observed, between the scientist and the experiment, becomes even more blurred. You wouldn't just be studying quantum mechanics, you would be quantum mechanics, thinking about itself through the medium of your awareness. But let's step back from these cutting-edge theories and consider something more immediate. Right now, as you breathe slowly and naturally, your body is performing quantum mechanical processes that are essential for life. The hemoglobin molecules in your red blood cells use quantum mechanics to bind and release oxygen with exquisite precision. The enzymes that digest your food rely on quantum tunneling to catalyze chemical reactions at body temperature. Even the DNA in your cells depends on quantum mechanical hydrogen bonds to maintain its double helix structure. These aren't exotic phenomena happening in specialized laboratory conditions. They're the everyday miracles that keep you alive, quantum mechanics operating in the warm, wet, noisy environment of your living body. Life has not only learned to tolerate quantum strangeness, it has learned to exploit it, using quantum effects to achieve levels of efficiency and precision that our best technology can barely match. Consider the process of photosynthesis happening in plants around the world right now. When a photon of sunlight hits a chlorophyll molecule, it creates what's called an exciton, a quantum mechanical combination of an electron and the hole it left behind. This exciton needs to find its way to the reaction center where photosynthesis actually occurs, navigating through a complex molecular maze. Classical physics would predict that this exciton would stumble randomly through the maze, losing most of its energy along the way. But quantum mechanics allows something much more elegant. The exciton can exist in a superposition of all possible paths simultaneously, exploring every route through the molecular maze at once until it finds the most efficient path to the reaction center. It's as if nature is using quantum computing to solve optimization problems that would challenge our most powerful computers. This quantum coherence in biological systems was once thought impossible. The warm, chaotic environment inside living cells should destroy quantum effects almost instantly. But nature has found ways to protect and exploit quantum coherence, using it to achieve near-perfect efficiency in processes like photosynthesis, and possibly even in the neural processes that create consciousness. As you lie there, your own body might be performing quantum computations that we're only beginning to understand. The microtubules inside your neurons, tiny protein structures that help maintain cell shape, have been proposed as quantum processing elements that could support conscious awareness. While this idea remains controversial, it highlights how the quantum world and the world of consciousness might be more intimately connected than we ever imagined. But even if consciousness doesn't directly involve quantum mechanics, the fact remains that you are a quantum being living in a quantum universe. Every chemical reaction in your body, every molecular interaction, every process that makes life possible operates according to quantum mechanical principles. You are not just made of atoms, You are made of quantum possibilities that have collapsed into the specific pattern that is you. Think about the incredible precision required for this to work. Your DNA contains about 3 billion base pairs, each one a quantum mechanical structure that must be copied with near-perfect accuracy every time a cell divides. The molecular machines that replicate DNA can detect and correct errors at the level of individual atoms, using quantum mechanical recognition processes to distinguish between correct and incorrect molecular structures. Your immune system uses similar quantum mechanical recognition to distinguish between your own cells and foreign invaders. Antibodies bind to specific molecular targets through quantum mechanical shape complementarity, like quantum keys fitting into quantum locks. The specificity is so precise that a change of just one atom in a target molecule can completely eliminate the binding. Even your sense of smell relies on quantum mechanics. When odor molecules enter your nose, they bind to receptor proteins that may use quantum mechanical processes to detect not just the shape of molecules, but their vibrational frequencies. This could explain how your nose can distinguish between thousands of different scents, even molecules that have the same chemical composition but different quantum mechanical properties. Your taste buds, your sense of touch, your ability to see color. All of these depend on quantum mechanical interactions between molecules and the specialized cells that detect them. You are constantly experiencing the quantum world through your senses, though the classical world of everyday experience emerges from the collective behavior of countless quantum events. This emergence is one of the deepest mysteries in science. How do quantum mechanical particles, following probabilistic rules and existing in superposition states, give rise to the classical world of definite objects and predictable behavior? How does the strange, uncertain quantum realm transform into the familiar, seemingly solid reality you experience? The answer seems to lie in something called decoherence. When quantum systems interact with their environment, their delicate superposition states quickly collapse into definite classical states. The larger and more complex a system becomes, the more rapidly it loses its quantum properties and begins to behave classically. Your body, made of trillions of atoms constantly interacting with each other and the environment, naturally exists in the classical realm, even though it's built from quantum components. But the transition from quantum to classical isn't sharp or absolute. There are scales and situations where quantum effects can still manifest in large systems. Superconductors, for instance, can maintain quantum coherence across macroscopic distances, allowing electrical current to flow without resistance. Some scientists speculate that biological systems might have evolved ways to maintain quantum coherence for brief periods, long enough to exploit quantum advantages for specific biological functions. This blending of quantum and classical properties makes you a unique kind of system in the universe. You're large enough and complex enough to exhibit classical behavior and conscious awareness, yet you're built entirely from quantum mechanical components that retain some of their strange properties, even in the warm, noisy environment of your living body. As you rest there, breathing slowly, let yourself marvel at this quantum classical duality that defines your existence. Every breath involves quantum mechanical processes as oxygen molecules bind to hemoglobin, yet you experience breathing as a smooth, continuous, classical process. Every thought in your mind emerges from quantum mechanical interactions between atoms and molecules, yet consciousness feels unified and classical. You exist at the boundary between two worlds, the quantum realm of probability and uncertainty, and the classical realm of definite objects and predictable behavior. You are a bridge between these two descriptions of reality, a living example of how quantum strangeness can give rise to classical familiarity, how uncertainty can create certainty, how the probabilistic can become definite. This perspective reveals something profound about the nature of emergence in the universe. Just as atoms emerge from quantum fields, and molecules emerge from atoms, and cells emerge from molecules, consciousness might emerge from the complex interactions of quantum mechanical processes in your brain. Each level of organization brings new properties and behaviors that couldn't be predicted from studying the components in isolation. You are not just the sum of your atoms, you are an emergent property of their collective behavior, a pattern of organization that has somehow achieved self-awareness. Your thoughts, your memories, your sense of identity, all emerge from the quantum mechanical dance of particles that individually have no consciousness, no memory, no sense of self. This emergence doesn't diminish you or make you less real. If anything, it makes you more remarkable. You represent one of the universe's greatest achievements, the organization of unconscious matter into conscious awareness. You are proof that the cosmos has the potential to understand itself, to appreciate its own beauty and complexity. And you're not alone in this achievement. Every conscious being, every living system that has emerged on Earth or might exist elsewhere in the universe, represents a similar triumph of organization over chaos, of information over entropy, of consciousness over mere matter. You are part of a cosmic awakening, the universe's gradual development of self-awareness through the evolution of complex systems like yourself. As we near the end of our atomic journey tonight, let's consider one final mystery that connects you to the deepest questions about reality itself. We've explored how atoms are mostly empty space, how they follow quantum rules, how they combine to create the rich diversity of matter around you. But there's something even more fundamental we haven't fully addressed, the question of what matter actually is at its deepest level. Modern physics suggests that what we call particles might not be particles at all, but rather excitations in quantum fields that permeate all of space. According to quantum field theory, the entire universe is filled with invisible fields, one for each type of particle. An electron isn't a tiny ball, it's a ripple in the electron field. A photon is a wave in the electromagnetic field. Even empty space isn't truly empty. It's a seething foam of quantum fluctuations in these underlying fields. This means that you, made of atoms, are actually made of field excitations, patterns of energy dancing in the quantum vacuum. The boundary between you and empty space becomes even more blurred when you realize that both you and the space around you are manifestations of the same underlying quantum fields. You are not separate from the vacuum. You are the vacuum, temporarily organized into a pattern complex enough to contemplate its own existence. This field-theoretic view of reality suggests that consciousness itself might be a field phenomenon, a pattern of organization that can emerge in any sufficiently complex system, regardless of its specific material composition. Just as electromagnetic fields can support waves and particles, perhaps there are consciousness fields that can support the patterns we experience as thoughts, feelings, and awareness. This is still highly speculative, but it points toward a universe that is far more unified and interconnected than our everyday experience suggests. If everything is made of field excitations, if consciousness is a field phenomenon, then the boundaries between mind and matter, between observer and observed, between self and universe, become much more fluid and permeable. You are not a separate observer looking at the quantum world from the outside. You are the quantum world, temporarily organized into a pattern that can observe and understand itself. The atoms that make up your body are not foreign objects that you happen to be made of. They are you, in the most literal and fundamental sense possible. This understanding brings us full circle to where we began, with the question of what reality is made of. The answer, it seems, is that reality is made of you. Not just physically, in the sense that you are made of the same atoms as everything else, but more fundamentally, in the sense that consciousness and matter might be different aspects of the same underlying reality. The universe doesn't just contain consciousness, it might be consciousness, experiencing itself through countless different perspectives, including yours. Every atom in your body, every quantum field fluctuation, every emergent property that makes you who you are, might be part of a vast cosmic mind awakening to its own nature. As you drift towards sleep tonight, carry with you this profound connection to the atomic realm and to the cosmos itself. You are not a stranger in a foreign universe. You are the universe becoming aware of itself. You are stardust that has learned to wonder, atoms that have achieved consciousness, quantum fields that have organized themselves into the pattern that experiences itself as you. The atoms that form your body will continue their cosmic journey long after your current pattern dissolves. But the consciousness that you are, the awareness that contemplates these words, that might be something even more fundamental and enduring. You are both temporary and eternal, both individual and universal, both matter and mind. Rest now in this knowledge, this deep connection to the atomic foundation of all existence. You are home in this universe because you are this universe, temporarily experiencing itself through your unique perspective. The atoms beneath your pillow, the atoms in your body, the atoms in the air around you, they are all part of the same cosmic story, the same quantum dance, the same magnificent pattern of existence, becoming aware of itself. Sweet dreams, fellow stardust. Until our paths cross again, in this grand atomic adventure we call existence. Your body right now is performing a symphony of atomic precision that would make the most advanced technology seem clumsy by comparison. Every second, millions of chemical reactions are taking place inside you, each one a carefully choreographed dance of atoms finding each other, bonding, transforming, and separating again, in endless cycles of creation and renewal. Consider the simple act of your heart beating as you lie there. The muscle contractions that pump blood through your body depend on calcium atoms flowing in and out of cellular chambers with split-second timing. These calcium atoms don't just randomly wander around, they're guided by protein channels that can recognize and select specific types of atoms with incredible precision. It's like having molecular bouncers at the door of every cell, checking atomic identification cards and only allowing the right particles to enter. The electrical signals racing through your nervous system right now are carried by sodium and potassium atoms, charged particles that flow across nerve cell membranes in waves of electrical activity. When you think a thought, when you form a memory, when you experience an emotion, you're witnessing the collective behavior of countless atoms organizing themselves into patterns of meaning and awareness. But here's something that might surprise you. The atoms in your body aren't permanent residents. They're more like travelers passing through, staying for a while before continuing their cosmic journey. The atoms in your skin are replaced roughly every few weeks. The atoms in your liver regenerate every few months. Even the atoms in your bones, which seem so solid and permanent, are constantly being broken down and rebuilt over the course of years. This means that the physical substance of your body is in constant flux. Yet your sense of identity, your memories, your personality, all remain remarkably stable. You are like a river that maintains its shape and character, even though the water flowing through it is always changing. Your consciousness is the pattern, not the particles. You are information organized in matter, not matter organized into information. This atomic turnover connects you to the entire biosphere in ways you might never have considered. The carbon atom that's part of a protein in your muscle right now might have been part of a tree last year, or floating as carbon dioxide in the atmosphere last month. The oxygen you're breathing could have been released by a plant on the other side of the world just days ago. You're not separate from nature, you're woven into it at the atomic level, part of a vast global circulation of elements that connects all life on Earth. But let's zoom out even further and consider your place in the cosmic story of atoms. The hydrogen in your body, the most abundant element in the universe, was created in the first few moments after the Big Bang, when the cosmos was a hot, dense soup of fundamental particles. As the universe expanded and cooled, protons and electrons found each other and formed the first atoms, hydrogen, in a process called recombination. For hundreds of millions of years, the universe was dark, filled with hydrogen gas, but no stars to light it up. Then gravity began to work its patient magic, pulling these hydrogen atoms together into vast clouds that eventually collapsed under their own weight to form the first stars. In the nuclear furnaces of these ancient suns, hydrogen was fused into helium, helium into carbon, carbon into heavier elements. When these first massive stars reached the end of their lives, they exploded as supernovas, scattering their newly forged elements across space. These stellar ashes became the seed material for the next generation of stars and, eventually, for planets like Earth. The calcium in your bones remembers the interior of a star that died billions of years ago. The iron in your blood carries the memory of a supernova explosion that outshone entire galaxies. This cosmic perspective reveals something profound about the nature of existence itself. You're not just a collection of atoms that happen to come together by chance. You're the universe's way of organizing itself into ever more complex and sophisticated patterns. From the simple hydrogen atoms of the early cosmos to the intricate molecular machinery of your cells, there's been a steady progression toward greater complexity, greater organization, greater awareness. This progression isn't random or accidental. It's driven by fundamental principles of physics and chemistry that favor the formation of stable, complex structures when the conditions are right. Atoms naturally seek lower energy states, and sometimes the path to lower energy involves forming bonds with other atoms, creating molecules with entirely new properties and capabilities. Over billions of years, this process has led from simple molecules to complex organic compounds, from organic compounds to living cells, from cells to multicellular organisms, and from organisms to conscious beings like yourself who can contemplate their own atomic nature. You represent the current frontier of this cosmic evolution toward complexity and consciousness. But the story doesn't end with you. The same principles that created you are still at work throughout the universe, potentially giving rise to other forms of consciousness, other ways for atoms to organize themselves into awareness. Every planet orbiting every star in every galaxy might be conducting its own experiments in atomic organization, exploring different pathways toward complexity and consciousness. This vast cosmic context doesn't diminish your significance, it amplifies it. You're not just a random accident in an indifferent universe. You're a pioneer, an explorer, a frontier of cosmic evolution. Through you, the universe is learning what's possible when atoms organize themselves with sufficient complexity and sophistication. Your thoughts right now, as you follow these words and contemplate these ideas, represent something unprecedented in the cosmic story. You're matter that has become aware of itself, atoms that have learned to wonder about their own nature, stardust that can contemplate the stars from which it came. This is not just remarkable, it's miraculous in the deepest sense of that word. And yet, for all our scientific understanding of atoms and molecules and quantum mechanics, the fact that consciousness emerges from matter remains one of the greatest mysteries in science. We can trace every chemical reaction in your brain, map every neural connection, understand the molecular basis of memory and emotion and thought. But the hard question remains: why is there subjective experience at all? Why is there something it's like to be you? Some scientists and philosophers suggest that consciousness might be a fundamental feature of the universe, like mass or electric charge, rather than something that emerges from complex arrangements of unconscious matter. Perhaps every atom, every particle, every quantum field has some minimal form of experience, and what we call consciousness is what happens when these micro-experiences combine and integrate in sufficiently complex systems. This idea, called panpsychism, might sound strange at first, but it offers an elegant solution to the hard problem of consciousness. Instead of asking how unconscious matter can give rise to conscious experience, we might ask how simple forms of experience can combine to create the rich, unified consciousness you experience as yourself. Whether or not consciousness is fundamental, one thing is clear. You are a remarkable achievement of atomic organization. The same forces that hold atomic nuclei together, that bind electrons to atoms, that allow atoms to form molecules and molecules to form cells, have somehow given rise to your ability to contemplate these very forces. You are the universe studying itself, atoms understanding atoms, consciousness examining consciousness. This recursive, self-referential quality of your existence points to something profound about the nature of reality itself. The universe isn't just a collection of objects in space and time. It's a process of becoming aware of itself through beings like you. Every time you learn something new about atoms or molecules or quantum mechanics, you're not just acquiring information, you're participating in the cosmos's ongoing project of self-discovery. Your curiosity about the atomic world isn't separate from that world, it's part of it. The wonder you feel when contemplating the quantum realm isn't external to quantum mechanics. It's an expression of quantum mechanics, a way that quantum fields organize themselves into patterns capable of appreciating their own beauty and strangeness. This perspective transforms your relationship to scientific knowledge from passive consumption to active participation. When you learn about atoms, you're not just learning about something outside yourself. You're learning about the fundamental constituents of your own being. When you study quantum mechanics, you're exploring the deepest laws that govern your own existence. When you contemplate the cosmic origin of elements, you're tracing your own genealogy back to the heart of ancient stars. Science becomes not just a way of understanding the world, but a way of understanding yourself, your place in the cosmic story, your connection to everything that has ever existed or ever will exist. The atoms that make up your body have been on an incredible journey through space and time, and now they're organized into the pattern that experiences itself as you, reading these words, thinking these thoughts. As you rest there in the gentle darkness, breathing slowly and naturally, let yourself feel this deep connection to the atomic realm. Every breath brings new atoms into your body and sends others back out into the world. You're constantly exchanging matter with your environment, participating in the great circulation of elements that connects all life on Earth and ultimately to the stars themselves. The boundary between you and the universe isn't as clear as it might seem. You're not a separate entity observing the atomic world from the outside. You are the atomic world, temporarily organized into a pattern complex enough to observe and understand itself. The atoms in your brain that are processing these ideas right now are the same types of atoms that exist throughout the cosmos, following the same quantum mechanical rules, participating in the same fundamental processes. This unity doesn't erase your individuality or make you less special. If anything, it makes you more remarkable. Out of all the possible ways that atoms could arrange themselves, they've somehow organized into the unique pattern that is you, with your particular thoughts, memories, experiences, and perspective on existence. You're a one-time only experiment in consciousness, a never-before-seen and never-to-be-repeated way for the universe to experience itself. Your atoms will continue their cosmic journey long after the pattern that is you dissolves. But the consciousness that you are, the awareness that contemplates these words, represents something precious and irreplaceable. You are a temporary window through which the universe glimpses its own nature, a brief candle flame of awareness flickering in the cosmic dark, illuminating the atomic foundations of existence. The story of atoms is still being written, and you're one of its authors. Every thought you think, every discovery you make, every moment of wonder and understanding contributes to the universe's growing awareness of itself. You're not just made of stardust, you're conscious stardust, aware stardust, stardust that has learned to love and create and dream and hope. As you prepare to drift into sleep, carrying with you this deep understanding of your atomic nature, remember that even in dreams, the quantum dance continues. The molecular processes that create and store memories, the electrical rhythms that generate the theatre of sleep, the chemical cascades that repair and regenerate your body, all of these depend on the same atomic principles we've explored together tonight. You are never separate from the atomic realm, because you are the atomic realm, experiencing itself from within. Every atom in your body is a universe of possibility, every molecule a masterpiece of quantum engineering, every cell a cosmos of coordinated atomic activity. You are not just in the universe, you are the universe, temporarily organized into the beautiful, complex conscious pattern that experiences itself as you. Rest now in this knowledge, this profound connection to the fundamental fabric of reality. You are stardust that has learned to contemplate the stars, atoms that have achieved consciousness, quantum fields that have organized themselves into the miracle of awareness. In the grand atomic symphony of existence, you are both the music and the listener, the dance and the dancer, the universe discovering itself through your unique and precious perspective. Sweet dreams, fellow traveler in the cosmic atomic adventure. Until we meet again in this endless exploration of what it means to be conscious matter in a quantum universe. And as you lie there in the gentle embrace of sleep's approach, let's explore one final frontier in our atomic journey tonight. We've traveled from the birth of elements in ancient stars to the quantum foundations of consciousness itself. But there's one more layer to uncover, one that brings everything full circle and reveals the most beautiful truth about your place in this atomic universe. The atoms that compose your body right now are engaged in something extraordinary. They're not just following the laws of physics passively, like billiard balls bouncing around a table. They're participating in what scientists call emergent complexity, where simple components combine to create behaviors and properties that are greater than the sum of their parts. Consider the hemoglobin molecule carrying oxygen through your bloodstream as you rest. This single molecule contains over 10,000 atoms, arranged in a precise three-dimensional structure that took millions of years of evolution to perfect. At its heart sits a single iron atom, the same element forged in the core of a dying star billions of years ago. But this iron atom isn't just sitting there passively. It's actively binding and releasing oxygen molecules with exquisite timing, responding to the chemical environment around it, playing its part in keeping you alive. This iron atom has no knowledge of its role, no intention to keep you breathing. It simply follows the quantum mechanical rules that govern its electron interactions. Yet somehow, through the collective behavior of countless such atoms, your body maintains the incredible feat of consciousness, of self-awareness, of the ability to contemplate its own atomic nature. This emergence of complexity from simplicity is happening at every level of your being. Atoms combine to form molecules. Molecules organize into cellular structures. Cells coordinate to create tissues and organs. Organs work together to sustain the living system that experiences itself as you. At each level, new properties emerge that couldn't be predicted from studying the components in isolation. But perhaps the most remarkable emergence of all is consciousness itself. The atoms in your brain, individually unconscious and unaware, somehow give rise to the rich inner world of thoughts, emotions, memories, and dreams. You are proof that the universe has the capacity to become aware of itself, to experience beauty and wonder, to ask questions about its own nature. This isn't just a philosophical curiosity, it's a scientific mystery that connects to the deepest questions about the nature of reality. How does subjective experience arise from objective matter? How do unconscious atoms create conscious thoughts? These questions sit at the intersection of neuroscience, quantum physics, and philosophy of mind, and they remain among the greatest puzzles in human knowledge. Some researchers are exploring whether quantum effects in the brain might play a role in consciousness. The microtubules in your neurons, tiny protein structures that help maintain cell shape, might be quantum processing systems that support the unified experience of awareness. While this idea remains controversial, it highlights how the strange world of quantum mechanics might be intimately connected to the mystery of consciousness. But even if consciousness doesn't directly involve quantum mechanics, the fact remains that your awareness emerges from atomic processes following quantum rules. Every thought you think, every memory you form, every moment of conscious experience depends on the precise choreography of atoms and molecules in your brain. You are a walking, breathing example of how the quantum world gives rise to the classical experience of being human. As you breathe slowly and naturally, feeling the gentle rhythm that has sustained you throughout your life, remember that this simple act involves a cascade of atomic interactions. Oxygen molecules bind to iron atoms in your hemoglobin, travel through your bloodstream, and release their precious cargo to cells throughout your body. These oxygen atoms then participate in the chemical reactions that extract energy from food molecules, powering the cellular processes that keep you alive and aware. The carbon dioxide you exhale carries away the atomic waste products of these reactions, returning carbon atoms to the atmosphere where they might be absorbed by plants, incorporated into new organic molecules, and begin their journey through the biosphere once again. You're not just breathing air, you're participating in the global circulation of atoms that connects all life on Earth. This atomic perspective reveals something profound about the interconnectedness of all existence. The oxygen you breathe was released by photosynthesis in plants, a quantum mechanical process that converts sunlight into chemical energy. The carbon in your body came from carbon dioxide in the atmosphere, absorbed by plants and passed up the food chain. The water in your cells has been part of oceans, clouds, rivers, and countless other living beings throughout Earth's history. You are not a separate entity, existing apart from the natural world. You are the natural world, temporarily organized into the pattern that experiences itself as you. Every atom in your body has been part of the Earth's biosphere for billions of years, cycling through rocks, oceans, atmosphere, and living beings in an endless dance of transformation and renewal. This cycling of atoms through different forms and organizations reveals something beautiful about the nature of existence itself. Nothing is ever truly lost or destroyed, only transformed. The atoms that make up your body will continue their cosmic journey long after your current pattern dissolves, becoming part of new structures, new patterns, new possibilities for organization and awareness. In this sense, you are both temporary and eternal. Your current form, your specific pattern of atomic organization, is unique and irreplaceable. But the atoms that make you possible are ancient travelers, billions of years old, carrying within them the history of the cosmos itself. You are a brief flowering of cosmic consciousness, a momentary arrangement of stardust that has learned to wonder about its own nature. This understanding transforms how we think about life and death, about meaning and purpose, about our place in the grand scheme of existence. Death isn't the destruction of matter, but the dissolution of a pattern, the return of atoms to the cosmic circulation from which they came. The atoms that make up your body are immortal in their own way, destined to participate in countless future patterns and possibilities. But consciousness, awareness, the subjective experience of being you, that might be something even more fundamental and enduring. If consciousness is a basic feature of reality, like energy or information, then your awareness might not disappear when your current atomic pattern dissolves. It might simply return to the universal field of consciousness from which it emerged, carrying with it the memories and experiences of having been you. These are deep waters, mysteries that science is only beginning to explore. But they remind us that the story of atoms is also the story of consciousness, of awareness, of the universe's capacity to know itself through beings like you. Every moment of conscious experience is a victory of organization over chaos, of meaning over randomness, of awareness over unconsciousness. As you rest there, feeling the gentle pull towards sleep, let yourself marvel at the atomic symphony playing out in your body right now. Millions of chemical reactions occurring every second, each one a precisely choreographed dance of atoms finding each other, bonding, transforming, creating the molecules of life. Your DNA being read and transcribed, your proteins folding into their functional shapes, your neural networks processing information and storing memories. All of this happens below the threshold of your conscious awareness, yet it's what makes consciousness possible. Your atoms are taking care of you, maintaining the incredibly complex pattern that experiences itself as your life. They don't know they're doing this. They don't have intention or purpose in any conscious sense. They simply follow the laws of physics, and somehow, through their collective behavior, they create and sustain the miracle of your existence. This is perhaps the most profound lesson of atomic theory, that consciousness and matter are not separate realms, but different aspects of the same underlying reality. You are not a mind trapped in a material body, nor are you just a complex machine without genuine experience. You are both, matter and mind, unified in the temporary but precious pattern that is your life. The atoms that make up your body are following the same laws that govern the behavior of atoms throughout the universe. The quantum fields that permeate your being are the same fields that exist in the depths of space, in the cores of stars, in distant galaxies, billions of light years away. You are connected to everything that exists through the fundamental forces and particles that make up reality itself. This connection isn't just poetic or metaphorical, it's literal, physical, measurable. The gravitational field of your body extends throughout the universe, infinitely weak but still present. The electromagnetic fields, generated by the electrical activity in your brain, propagate outward at the speed of light, carrying information about your thoughts into the cosmos. Even the quantum fields that make up your atoms are entangled with quantum fields everywhere else in the universe. You are not isolated or alone in this vast cosmos. You are woven into its very fabric, connected to every star, every planet, every other conscious being, through the shared foundation of atomic reality. When you look up at the night sky, you're not seeing something foreign or distant. You're seeing your cosmic family, the stellar nurseries where your atoms were born, the gravitational fields that shape the evolution of the universe, the light that connects all things across space and time. The photons entering your eyes right now began their journey from distant stars years or even centuries ago. They've traveled across the emptiness of space, carrying information about their stellar origins, only to end their cosmic voyage by triggering molecular changes in your retina that become the experience of seeing starlight. You are the destination of these ancient photons, the culmination of their journey across the universe. And when you close your eyes and drift towards sleep, you're not withdrawing from the cosmic drama. You're entering a different phase of participation where your brain processes the day's experiences, consolidates memories, and prepares for tomorrow's adventures. Even in sleep, the atomic dance continues, the quantum processes that sustain life operating with perfect precision, while your consciousness explores the mysterious realm of dreams. Dreams themselves might be atomic phenomena, patterns of neural activity that create the subjective experience of narrative and imagery while your body rests. The same atoms that participate in waking consciousness reorganize themselves into different patterns during sleep, creating the theatre of dreams where impossible things become possible, where the normal rules of physics and logic bend and flow like water. As you approach that threshold between waking and sleeping, between conscious awareness and the mysterious realm of dreams, carry with you this profound understanding of your atomic nature. You are not separate from the universe you inhabit. You are the universe, temporarily organized into the pattern that experiences itself as you. Every atom in your body is a universe of possibility. Every molecule, a masterpiece of quantum engineering. Every cell, a cosmos of coordinated activity. You are both ancient and modern, both temporary and eternal, both individual and universal. You are stardust that has learned to love. Atoms that have achieved awareness, quantum fields that have organized themselves into consciousness. The story of atoms is your story because you are atoms. Their journey through space and time is your journey. Their transformation and evolution is your transformation and evolution. In understanding atoms, you understand yourself. In appreciating their beauty and complexity, you appreciate your own beauty and complexity. Rest now in this knowledge, this deep connection to the fundamental fabric of reality. You are home in this universe because you are this universe, experiencing itself through your unique and precious perspective. The atoms beneath your pillow, the atoms in your body, the atoms in the space around you, they are all part of the same cosmic symphony, the same quantum dance, the same magnificent pattern of existence, becoming aware of itself. Sweet dreams, fellow stardust. In sleep, as in waking, you remain forever connected to the atomic heart of all existence, a conscious expression of the universe's endless creativity and wonder. Until consciousness calls you back to another day of atomic adventures, rest well in the knowledge that you are both the observer and the observed, the questioner and the answer, the universe discovering itself through the miracle of your awareness. Tomorrow, when you wake and open your eyes to greet another day, you'll see the world with new understanding. The morning light streaming through your window isn't just illumination. It's a river of photons that began their journey in the nuclear furnace of the sun, traveling 93 million miles to dance with the atoms in your retina and create the experience of sight. The coffee cup you hold will no longer be just a simple object, but a marvel of atomic architecture. Silicon atoms from ancient sand, aluminum from stellar explosions, all bound together by electromagnetic forces into crystalline structures that give your cup its shape and strength. The steam rising from your morning drink carries water molecules, each one a tiny masterpiece of hydrogen and oxygen atoms, sharing electrons in quantum mechanical bonds. Even the simple act of taking a sip becomes a celebration of atomic complexity. Caffeine molecules, crafted from carbon, hydrogen, nitrogen, and oxygen, will journey through your bloodstream and interact with receptor proteins in your brain. Each molecular recognition event, a quantum mechanical lock and key mechanism that ultimately enhances your alertness and awareness. But perhaps most remarkably, you'll remember that the very act of remembering, the formation and recall of memories about atoms and consciousness and cosmic connections, depends on the same atomic processes we've explored tonight. Your memories are patterns of molecular change in your neural networks, quantum mechanical modifications to protein structures that encode information in the language of atoms themselves. You are both the reader and the story, the scientist and the experiment, the universe and its own autobiography. In learning about atoms, you haven't just acquired new information, you've participated in the cosmos's ongoing project of self-discovery. You are proof that matter can become conscious, that atoms can achieve awareness, that the universe has the capacity to understand its own deepest nature. The night sky above you, whether visible through your window or hidden by clouds and city lights, continues its ancient dance of atomic transformation. In stellar cores across the galaxy, hydrogen atoms are fusing into heavier elements, continuing the cosmic alchemy that makes complex chemistry and life itself possible. Somewhere among those distant stars, other arrangements of atoms might be achieving their own forms of consciousness, their own ways of contemplating the atomic nature of existence. You are part of that vast community of conscious matter, a member of the universe's family of self-aware beings. The atoms that make you possible connect you not only to the Earth and its biosphere, but to every star, every planet, every possible form of life throughout the cosmos. You are a local expression of universal principles, a unique voice in the cosmic conversation about the nature of reality itself. As sleep finally embraces you, as consciousness gently fades into the mysterious realm of dreams, the atomic symphony continues. Your heart beats with calcium-controlled precision. Your lungs exchange gases through quantum mechanical processes. Your brain consolidates the day's experiences into long-term memories through molecular mechanisms we're still working to understand. Even in the deepest sleep, you remain a miracle of atomic organization, a temporary but precious arrangement of stardust that has somehow learned to love, to wonder, to dream. You are the universe's gift to itself, a way for the cosmos to experience beauty, to ask questions, to seek understanding about its own magnificent nature. The journey from ancient stellar furnaces to conscious awareness is written in every atom of your being. You are both the author and the story, the question and the answer, the seeker and the sought. In you, the universe has achieved something extraordinary, the ability to contemplate its own existence, to appreciate its own beauty, to wonder about its own deepest mysteries. Rest now, knowing that you are forever connected to the atomic heart of all existence. You are stardust that dreams, quantum fields that love, cosmic matter that has awakened to its own infinite potential. In the grand atomic story of the universe, you are both a single sentence and the entire narrative, both a moment in time and a bridge to eternity. Sweet dreams, conscious cosmos, until tomorrow's light calls you back to another day of atomic wonder. Sleep peacefully in the knowledge that you are exactly what the universe intended when it first began learning how to think, how to feel, how to become aware of its own beautiful, mysterious, endlessly creative nature. The atoms sleep when you sleep, and wake when you wake, and in between, they dream the dreams that make all existence possible.